Good morning and welcome to today's webinar sponsored jointly by ASQ's Six Sigma Forum and the Statistics Division. My name is Harry Rowe. I'll be the moderator today. I will be introducing our speaker in just a moment, but first we need to cover some housekeeping details. As you heard just a moment ago, in order to prevent extraneous noise during the presentation, all attendees' microphones are currently muted. We encourage you to ask questions, but they'll need to be typed in. If you look at your screen, you should see over in the right margin, at least that's where it is on my browser, you should see what looks like a little speech bubble from a cartoon that has a question mark in it. And if you click on that button, you'll get a little panel that you can write your question in and then press return so that we'd be able to see your question whenever you finish typing. And then at the end, we plan to have a question and answer period to answer all of those questions. Once again, looks like we have I've got a screen here that tells me how many people are attending. We have 132 of our roughly 350 people who had registered for the presentation. So I think we'll go ahead and get started. I will introduce the speaker and then we can get on with the webinar. The title of today's webinar is How to Set Up, Perform, and Analyze an Attribute Agreement Analysis. Our speaker today is Scott Sturbins. Scott is a Six Sigma Master Black Belt at Ford Motor Company in Dearborn, Michigan. He's been in this role since 2001, and his job is to solve customer satisfaction and quality issues using the Six Sigma methodology. Outside of Ford, he also serves as a volunteer technical advisor for the United States Bowling Congress, which is the governing body for the sport of bowling in the U.S. And there he helps to develop test plans and data analysis methods to set specifications for the bowling lanes, the pins, in addition to doing research for the sport. He's a licensed professional engineer in the state of Michigan, a three-time ASQ Global Team Excellence Award finalist. He holds bachelor's and master's degrees in mechanical engineering from Wayne State University, having graduated first in his class in both programs. In his spare time, he enjoys mountain biking and motorcycling. And once again, let me remind you, for anyone that joined us after the initial announcement, all attendees' microphones are muted. Questions can be entered through the web interface. Look for the little icon with a question mark in it. Click on that, and you can type in your question. And at the end, we will address the questions. So without further ado, let me turn this over to Scott, and we can begin the presentation.
All right, thank you, Harry, very much. I appreciate the wonderful introduction. I want to thank everybody who registered to see this webinar today and tune in. I wish you a good day, regardless of where in the world you are. I think that you're going to find this presentation and the session very valuable, and my goal is always to encourage practitioners to practice what we show in these webinars so that you can be successful in your daily work. So again, my name is Scott Sturbins, and we're hosting this jointly between the Six Sigma Forum and the Statistics Division of ASQ. It's very exciting for us to get together and collaborate on this type of presentation. So measurement system analysis and performing an attribute agreement analysis. By the end of the session today, you will be able to understand why the attribute agreement analysis is important and why it's an important part of the measurement system analysis for any type of problem solving that you're doing. You're also going to know how to set up and analyze an attribute agreement analysis for nominal attribute data, and then also for ordinal attribute data as well. Many of you may already know how to set up and run a gauge R&R or a measurement system analysis for variable data. But a lot of times what happens is that we're stuck in a situation where we have attribute data, whether it's nominal or ordinal in nature, and I'll get to that in just a minute, what the difference is between the two. And we can't use variable data. But as it turns out, it's just as important for us to run an attribute agreement analysis when you have that attribute data. So just like with in the Six Sigma process, this applies for any problem-solving process. Whenever you're taking measurements, you need to make sure that you're trusting your data. And you never want the nagging questions that are going on in the back of your head, asking yourself, is your data accurate? Or if you have multiple people taking measurements throughout your project, you don't want that nagging question if they're all getting the same answer. You want to make sure that that data that you're taking is accurate and it's precise. And the reason why that comes into play is because every decision that we make in a project is very important. And whether we're running any type of statistical comparison test or a design of experiment, or even deciding when to repair or scrap a part, you have to trust the measurements that you're taking because these decisions are very important. As a practitioner, what I can tell you is that whether I've been working with variable data or attribute data, if after I perform a measurement systems analysis and I find that the results of that MSA are poor, most of the time the poor results are a result of a poor or non-existent operational definition. So what I mean by that is that when we run a gauge R&R or some type of measurement system analysis, we have some type of standard operating procedure for how to use the gauge. So the gauge R&R is not necessarily just on the measurement system itself, but it's also on how the operators are using that gauge. So as I said before, a vast majority of the time, if we find that the operators are not using the gauge the same way or following the standard operating procedure, that's most of the reason why the gauge R&R turns out to be poor. However, sometimes we also find, and this is a much lesser extent, that there are some parts or some things that you're assessing where the assessment or the measurement is very difficult. And the nice part is that some of the graphical summaries and some of the statistical summaries that were given in our software packages will tell us that. And then finally, probably the least reason where I find that gauge R&Rs they don't come out as good as we think they should is because of an inaccurate, insufficient, or uncalibrated measurement device. So in essence, the purpose of an MSA is to assess the error in a measurement system that I said as before is not only caused by the measurement device itself, but it's also by the way that the operators are using the device. And the error that is reported in an MSA can be partitioned into two specific sources, and those are specifically accuracy and precision. So as a reminder, accuracy is going to relate to calibration, and it's going to assess whether the average of the assessor's values over time are correct. So if you take a look at that bullseye that I got up at the top of the slide over here, you can see that, yeah, all the measurements are kind of right around the target, and if I took the average of the three, it's probably right about on that bullseye. So that's what accuracy talks about. But precision is something that's completely different. So precision relates to the consistency of the answers over time. So again, you can see the bullseye now that's up on the right top of the screen shows a bunch of darts that, although they're far away from the target, they're very, very closely clustered together. So those would be considered precise. The precision can be categorized as one of two categories, and this is where the R&R and gauge R&R comes from, the repeatability and reproducibility. So as a reminder, for those that are familiar with gauge R&R, repeatability is what we call the within variability. So within the same operator or within the same person or measurement device. And then reproducibility would be the between variability. So that would be between operators, as a for instance. So the gauge R&R or the measurement system analysis is going to assess both of those, the repeatability and the reproducibility. The one guideline to remember is that although you may be accurate, you may not be precise. And likewise, just because you're precise doesn't mean that you're accurate. And our goal in an MSA is to make sure that we're both accurate and precise. Those of you that might be familiar with a variable gauge R&R probably recognize the graphic that I'm showing here on the screen. The method that we use to perform any type of MSA or attribute agreement analysis involves multiple operators assessing multiple parts multiple times. So what this graphic here is showing on the bottom of the screen is that I may have in my gauge R&R study 10 parts assessed by 3 operators, but each of those 3 operators are looking at the same parts more than once, and in this case it's specifically twice. So here the repeatability is going to be between trials 1 and 2 within each operator, and then the reproducibility is going to be assessed between operators 1, 2, and 3. There are a couple of other notes that I want to get into before I start talking specifically about setting up and helpful hints for an attribute gauge R&R or an attribute agreement analysis. The first is that if you're collecting variable data and you're running a variable gauge R&R, if I take the product of the parts, operators, and trials, that product should be greater than 40 with at least 5 parts represented in your study. The more important thing is that if you can control it, the parts that you select for the gauge R&R study should represent the range of observed variability. That's a pretty important thing, because if you don't achieve that part for the study, you're going to find that perhaps your percent study variation is not going to be quite representative, because that calculation is based off of the part variability that you choose for your gauge R&R. For attribute data, naturally the sample size is going to be a little bit bigger. We all know that, just because when you use attribute data, we know that our sample sizes have to grow. So when you have 2 categories, the product of the parts, operators, and trials should be greater than 200, with at least 50 parts represented. If you have more than 2 categories for your attribute agreement analysis, then you're going to have to require more parts. And the other thing to remember is that all attribute categories should be equally represented, as well as what I call borderline parts. And I want to just reiterate that third bullet point here again. If you have, for instance, let's say 3 or 4 categories that you are having in your attribute agreement analysis, and you have, let's say, 75 or 100 parts, you shouldn't have a vast majority of your parts representing one category and not a lot of parts representing your other categories. You want to make sure that, for instance, if you had about 75 or 100 parts and you had 4 categories, that each part was represented, or each category was represented about 25 times. It doesn't need to be exactly 25 times, but it needs to be approximately 25 times so that they're well represented. The other thing is with regarding borderline parts. So what do I mean by that? The last thing that you want to have is that you have all measurements that are quote unquote easy to assess. The whole purpose of having this attribute agreement analysis is to put some parts in there, or put some assessments in there that might be tricky, because those are the ones that you need to make sure that you're able to trust the assessor's assessment of those parts. So that's what I mean by borderline parts. When you're picking parts to be represented in this type of analysis, you want to make sure to select some that are going to be a little bit tricky for people to assess, and I call those borderline parts. Now I'm going to talk to you about the difference between nominal data and ordinal data when we talk about attribute type data. So nominal data is data that can be placed into 2 or more categories, but those categories have no natural ordering. So as an example, we might have pass or fail. We might have colors like blue, green, red, or yellow. So certainly those are attribute in nature, but those categories don't have any natural ordering. As a contrast, let's take a look at ordinal data. So ordinal data, again, is attribute data that can be placed into 3 or more categories, but those categories have natural ordering. We've seen these types of scales all over the place. So if you, for instance, are filling out a survey, we might have some choices that run from unsatisfied all the way up to satisfied. You might have some type of numeric scale or a Likert scale where you're rating something on a scale from, let's say, 1 to 5 or 1 to 10. So that's essentially the difference between nominal and ordinal data. And before you run an attribute agreement analysis, you need to know what type of attribute data you have, whether that data is nominal in nature or whether that data is ordinal in nature. The first example that I'm going to present to you is a very, very simple example. It's going to be a nominal attribute gauge R&R. So we're going to go through that one first, and then we're going to do an ordinal gauge R&R. And I'll be straight up honest with you guys, is that it's much easier to run a nominal gauge R&R than it is to run an ordinal gauge R&R. So I have some extra helpful hints when it comes to running an ordinal gauge R&R. So the example that I want to show you, and I don't want you to criticize me for the sample size because this is just an illustrative example. So this is similar to a true-false test. So I've got 10 questions that I'm going to ask my assessors. And based on what the assessors hear, they're either going to tell me that the statement that I give them is true or the statement that I'm going to give them is false. So as an example, I work for an automotive company. So let's say that I'm training some of my models that are going to be showing off some of our brand new vehicles at an auto show. And I want to make sure that they understand the facts about those vehicles well. So maybe about horsepower or perhaps luggage space in the back, or certain features or options that are available on certain trim levels. So I might put together a list of questions in which the model must answer true or false. In this table, I have in the attribute column the correct answer to that question. And then I have each assessor answer the questions in random order twice. So if you see the columns Ann trial 1 and Ann trial 2, and then Tom trial 1 and 2, and then Chris trial 1 and 2, those are each of my 3 assessors that are answering the questions twice. So when you look over that table and you just take a look at what I might be trying to get out of this example, 3 questions come to mind. The first is, does each appraiser answer consistently? So what I mean by consistently is, at least within themselves, do they answer the same each time they're given the same question? So that again is going to look at repeatability, the within variation. The second question you might be asking yourself is, well, do the appraisers agree with each other? So regardless of whether the answer is right or wrong, do they agree with each other? And that's the reproducibility part. So that is between assessors. And then finally, and just as important, is if the operators answer correctly when compared to the standard or the key. So in other words, I just don't want them to be able to answer the same within themselves, the same between each other, but they've also got to make sure that they're giving the correct answer according to the key. So let's see how we're going to take a look at this in our statistical software. Now, the software that I'm showing you how to use is Minitab. That's the software that Ford Motor Company uses as our statistical package. If you use another package like JMP or something similar, the dialog boxes are going to look a little bit different, but they are reasonably similar. So within Minitab, you can find the attribute agreement analysis under quality tools, and then attribute agreement analysis. And I've shown the way that you would fill in the dialog box here on the right-hand side of the screen. There are a couple of things that are important to fill out. So the first thing that you want to take a look at is you need to tell Minitab or whatever software you're using the number of appraisers that you have and the number of trials per appraiser. Then in addition, you need to indicate to the software whether you have a key, which was our attribute column. And then in addition, Minitab also needs to know whether the categories are ordered or not. So in other words, this box here is asking, hey, is this attribute data ordinal or is it nominal? In this case, because it's true or false, There's no order to that data. It's just nominal in nature, so we're going to leave that box unchecked. So I'll leave this screen up here just for a second in case you wanted to take a screenshot of it so that you could see how you fill out the dialog boxes in Minitab for nominal data. When you finally wind up clicking OK in this dialog box, Minitab is going to produce a lot of information in the session window, and Minitab will also produce one graph. Unfortunately, the graph that Minitab produces when you get in this particular way is not very useful, so you can shut that right down. So we're going to go right to the session window. We're going to take a look at repeatability first. So remember, repeatability is within a given operator. So this does not matter whether the operator is giving the correct answer or not. This is just telling us whether they're agreeing within themselves. So the first part of the table is going to tell us for each operator what percentage of the time do the assessors match themselves. And in this case, you can see that for all three operators, they all matched all 10 questions. So again, this isn't assessing whether they're given the correct answer, whether they're agreeing with each other. This is just whether they're agreeing within themselves. Did they give the same answer to the question both times it was asked? The second table is where I'm going to introduce you to something called the kappa value. The kappa value is shown here in this particular column right here, the kappa value. Okay? The kappa value is an assessment of how much better than chance the assessors perform. And I'll get into that in a little bit more detail here in just a second. What I do want to indicate to you is that the kappa value is going to range between -1 and +1, where 1 is the best possible result that you can get. So as an example, if I were given a true-false test and 5 of the answers were false and 5 of the answers were true, and I were just guessing at what the right answer was, I would expect to get 50% of them correct. Or I would expect that in the case where I'm looking at within agreement, that I would match myself 50% of the time if I were just guessing. In that case, if I were to have matched 5 out of 10 within myself, I would have scored a kappa score of 0 because that matches exactly what chance would have predicted that I would have matched. So as I get more than 5 correct within myself, the kappa value is going to increase to the positive side. And as I get less than 5 correct, the kappa value is going to decrease to the negative side. So in fact, if I were to get all of them wrong, if I were to get completely opposite answers for all 10 questions, I would score a -1. And naturally, if I get all 10 correct, I'm going to score a +1. So the kappa score is an assessment of how much better than chance a person performed. So because everybody matched 10 out of 10 within themselves, everybody received a perfect kappa score, which you can see in this column here. Next, we're going to take a look at accuracy. So this is where we're taking a look at each appraiser versus the standard. So this is where we're trying to see, okay, first I saw whether they agreed within themselves. Now I'm looking to see whether they agreed with the key. And what we can see here in this first part of the table is the percentage of times that each assessor matched the key. So Ann matched 10 times out of 10, Chris matched 10 times out of 10, but Tom looks like he missed 1. So he matched only 9 times out of 10. Now what's interesting here is that if you remember, Tom agreed with himself 100% of the time. But what happened here is obviously he gave the wrong answer to one of the questions, but at least he was consistently wrong. That's how I can use the first table and the second table in conjunction with each other. Now let's take a look at the second table. The second table tells us, what did the assessors not get right? So what this table is telling us is that Tom gave one assessment of true when the answer should have been false. That's what the second table is telling us. The third table is giving us an assessment of the kappa value. So again, because Ann and Chris got everything correct with respect to the key, you would expect them to score 100% on kappa. It was a perfect score. But Tom You would not expect to get a 1 for the kappa value, but he still did better than chance because his kappa value was positive at 0.78. Finally, we're going to take a look at reproducibility. So again, what reproducibility is it doesn't care whether they got the answer correct. It only cares on whether they matched each other. And so obviously, if there was one that they got the wrong answer to the key and the other two got the correct answer to the key, there's automatically going to be one that is not going to match. And that's what shows in this table here. So 9 out of 10, the assessors matched each other. The table below that, again, is going to be an explanation or an expression of the kappa value, and it's going to measure how much better than chance the assessors performed. So naturally, they did much, much better than what chance would expect. That's why the kappa value is so high, and in fact, it's at about 0.88. Then finally, it takes a look at what percentage of the time did all the assessors match the key. So what it's looking at here is not only did the assessor have to match themselves, not only did they have to match each other, but this is how many times all that happened in addition to them matching the key. And of course, that's going to happen 9 times out of 10 based on the results that we saw before. All the way at the bottom of the session window, Minitab is going to give us an assessment of the final result. So it takes everything into account. It takes into account the repeatability. It takes into account the reproducibility. And then it takes into account as well the match to the key. And it reports to us a final kappa value. So again, that final kappa value takes into account everything that we've looked at, the repeatability, the reproducibility, and matching the key. And we can see here that based on the kappa value, the assessors did approximately 92.6% better than chance. Now, a couple of notes on this. With only 2 categories, the kappa value is going to be the same for both categories, and that's going to be the kappa value that you're going to report. So when somebody asks you, hey, how did that attribute assessment turn out? You can say, well, hey, I got a kappa value of 92%. They're going to understand what you mean by that. However, when you have 3 or more categories, a kappa value is going to be reported for each category, and then there's going to be an overall kappa value. The value that you want to report is the overall kappa value. And the reason why that there's a kappa values for each category is so that you can do some troubleshooting and you can determine which categories your assessors are having problems with. And we'll see that in the example that I show a little bit later. There's always a question on what is considered the accepted kappa value for a good attribute agreement analysis. There are many tables and opinions that you're going to find out on the internet and reference sources as far as the kappa value. And the one that I see most often that is listed is that is a kappa value of greater than 0.7. Sometimes I see a kappa value of greater than 0.8. I'm going to warn you of this. The acceptable kappa value is going to be very strongly based on the situation that you have at hand. So if you have a situation where the kappa value, let's say, or an assessment is determining a safety item or a critical item, you don't want your kappa value to be anything less than 1.0. And I can give you an example of that. So there was an attribute assessment agreement analysis that I was doing on a latch that was in a Ford Motor Company product. And this was right after we started building some vehicles for a launch. The vehicles had not been shipped from the plant yet. They were still at the plant. But we had a supplier that had approached us saying that they had installed a particular rubber bumper in one of our latches upside down. And that was causing the latch not to function properly. So we had a number of vehicles that were parked in the lot that needed to be inspected. So we set up a gauge that the supplier provided us where we could do an assessment of whether that rubber bumper was installed right side up or upside down. When we did the attribute agreement analysis on it, we got a fairly good result, but the kappa value only came back at about 0.85. And even I was one of the assessors, And even in that case, I had some cases where the first time I assessed it, it was upside down. And then the next time I assessed it, the gauge said it was right side up. You can imagine that could have put us in quite the quandary at Ford Motor Company if we missed just a single one. If we had missed a single one at that plant that was installed incorrectly, we would have had to had a campaign on the entire lot of vehicles. We came up with, instead, we used a medical borescope that we were able to stick inside of the latch of each door. That medical borescope was able to tell us exactly whether that rubber bumper was installed right side up or upside down. And we got a kappa value on that attribute agreement analysis of 1.0. So what my guidance is to you is that I actually feel that when you have a key, so you have a known right answer, that you should strive to get a kappa value of 1.0. So in other words, everybody agrees with themselves, everybody agrees with each other, and everybody agrees with the key. There are going to be very rare cases in an attribute agreement analysis for nominal data where you don't have a key. And the general guideline is that a kappa value of greater than 0.7 is desired. And like I said, this is not as critical because there is no known right or wrong answer. So you have to give a little bit more leeway in the amount of agreement that you're going to have. Fortunately, the Minitab assistant can also be used to analyze a nominal attribute gauge R&R, but there are a couple of restrictions on it. So the first is the data has to be arranged in a traditional stacked format. That's just the way that you stack your data in Minitab. You can only have two possible responses. So in other words, you can only have two categories. You have to have a key, and the Minitab assistant is not going to report a kappa value. Instead, it is going to report a strict accuracy rate. So in other words, percent of match. However, I will give you guidance that just like with the kappa value, the level of acceptance for the attribute agreement analysis is going to be based on your particular situation. So in other words, if it's safety related or a critical measurement, you're going to aim for an accuracy rate of 100%. So this is an example of how you would have the data entered into Minitab in the stacked format. And then this shows you where in the Minitab assistant you would find the choice for attribute agreement analysis. And then finally, this is how you would fill out the dialog box for that attribute agreement analysis within the Minitab assistant. So you can see that many of the things are very similar to what we've seen before. The output that Minitab gives is very useful. It's very nice that you can just pop it from Minitab into a PowerPoint or into a Word document. So first, they're going to give you an assessment of accuracy to the key. So again, it is going to give you specifically a rating of the percent accuracy. So you can see that these numbers for my three operators are reported as 100%, 100%, and 90%. And then you have the overall percentage up here in this summary bar up on top. The next thing that the Minitab assistant will report to us is who got what wrong. So again, you can see that while Ann and Chris got everything correct, you can see that Tom was the one that gave one wrong answer. And then finally, part two of who got what wrong. This gives us an assessment of who got it wrong, and then also whether they got true when they should have said false, or when they said false rather than getting true, and that is going to be shown up here on the top right. So the true when it was actually true and it was rated false, or when it was false but it was rated true. So all of this is exactly the same information that we saw before. Depending on the type of audience that you're presenting to, you might want to show the results from the session window. Or if you don't have an audience that might be familiar with the kappa value, what the kappa value means, and you don't feel like explaining it to them, you can use the results from the Minitab assistant instead. Now let's take a look at for ordinal attribute gauge R&R, or ordinal attribute assessment agreement. So a couple of things to remember here is usually for ordinal data, there is going to be no key. And the thing that we want to remember with ordinal data is that our directional agreement is much more important than absolute agreement. So what do I mean by that? Well, let's say that we had a group of people and we said, you know what, I've got these 5 restaurants here, and I want you to rate the how much you like these restaurants on a scale from 1 to 10. And let's say that you have in that group of 5 restaurants, let's say that you have one restaurant that's really, really good. They've got outstanding food. They've got a nice menu that satisfies everybody. Their service is fantastic. And then you have another restaurant where the food is very specialized. The service isn't very good. The quality that comes out of the kitchen is only so-so. So for the first restaurant, if I have my assessors and they all rate it, let's say an 8 or a 9 or a 10, that's good. They don't exactly agree on what the rating is, but they're directionally all the same on my scale. And then if I take a look at the poor restaurant, if everybody rates those like a 2, a 3, and a 4, that's okay, because although they don't exactly agree, they agree directionally on my scale. So that's what I mean by directional agreement being more important than absolute agreement when I have an ordinal type of measurement. Now, because of that, I want to remind you that the kappa value measures absolute agreement, while the Kendall's coefficient is going to measure directional agreement. So we're going to use the Kendall's coefficient of concordance instead of the kappa value. And this statement is just a reminder of what I just said, where kappa value is going to represent the absolute agreement. So that's not going to be of use to us in this case, whereas Kendall's coefficient is going to measure directional agreement, and that is going to be useful to us. In general, as an acceptance guideline, we're going to take a look for a Kendall's coefficient being greater than 0.7 in order for us to find an acceptable gauge. Now, if you remember, just a little bit ago, I said that running an ordinal attribute assessment agreement is going to be a little bit more difficult than running a nominal attribute assessment agreement. So here are a couple of helpful hints for you. First is that the ordinal scale should have at least 5 choices, but no more than 10. And then the second thing is that you want to lay out boundary samples in advance so that your assessors understand what they're looking at. So let me give you an example of that. So if I were to ask you, as a for instance, rate the acceleration rate of the following vehicles between 1 and 10, where 1 is the fastest. And the first vehicle I show you is this Chevy Traverse. You go, well, okay, that's not a very fast vehicle. It's not really offered, the base engine doesn't offer a turbo or anything like that. It's just an inline 4. It's relatively slow, so I'm going to rate that one a 7. Then I show you a second vehicle, which is the 2019 Ford Ranger. You can say, oh, I've read about this truck. It's got a turbo 4, which is the same engine as is in the base Mustang, but it's a little heavy, so it's not going to be the fastest, but it's definitely faster than that Traverse, so I'm going to rate that one a 4. And then I show you a third vehicle, and it's this beautiful Mustang Shelby. You say, wow, that car is really fast. I'm automatically going to rate that a 1. But then you continue the study, and the next thing that you see is this Toyota Prius. And you go, oh gosh, that thing's as slow as a dog, so I'm going to rate that as 10. Now you go further into the study, and all of a sudden pops up this Ford GT. And you go, oh no, I already gave the Mustang Shelby a 1. What am I going to do with this? And you go, oh boy, I ran out of scale. What do I do? And then further in the study, I show you this thing, the smart car, and you go, oh, I already rated the Prius a 10. What am I going to do? Oh no. So this is why you want to be sure that you show your operators the boundary samples in advance so that they know the boundaries. Otherwise, what's going to happen is that you run out of scale and you're not going to have any resolution on the high and the low end of your scale. The other thing that's nice is that by having these boundary samples, you know from your process what is going to be the best and the worst. Sometimes it does help to have those boundary samples on hand so that assessors know exactly what they're going to be looking at. They can be reminded, and that's going to help you with your precision. Another hint I'm going to give you is that if you have a scale on things that get progressively worse, I always sign 1 as perfect and the highest number as the worst. So I'll give you an example. This is an actual example of foam quality, one of our interior parts. So you can see on the left, the foam bucket that's rated a 1, it has no voids in it. It looks very, very uniform. So we rated that a 1, that's perfect. Then as we start going to the right with the ratings of 2, 3, 4, 5, and 6, they start getting progressively worse with voids and some uneven foam formation and things like that. Well, the question is what's going to happen if I see something that's worse than a 6? Well, I can always go up to a 7 and an 8. Whereas if I would have rated the worst one a 1, and I got something that was worse than a 1, what am I going to do? Am I going to go down to 0 and -1? So it's much easier to shift the scale if you always make 1 as perfect, and then you go up from there. It's going to save you a lot of problem later. So that's a helpful hint. The only thing is you've got to remind your participants that that's how you set up the scale, because people are not used to seeing as 1 as perfect. Now let's take, I'm sorry, one bullet point that I missed here is that if your MSA does not pass, you can identify the troublesome parts from the summary table that you're provided in your software package, and you can have the assessors discuss what they did or did not see in that particular sample, and you can use that as training. So how do we set up an ordinal attribute agreement analysis in Minitab? Well, first what you can do is I show you an example here. This is the example of the vehicles and the acceleration rate. So you set up your data in a stacked format. So what you can see is that I have each assessor assessing 10 vehicles twice. So these are the 2 assessments from Tom. And then below that, I'm going to have the 2 assessments from Dave. And then below that, I'm going to have the 2 assessments from the 3rd assessor. The next thing that you're going to do is you're going to fill out your columns in the dialog box, but don't forget this checkbox down here. This checkbox down here is going to indicate that we have ordinal data, and Minitab and your other statistical software needs to know that you have that ordinal data so that they know that it needs to report the Kendall's value, not the kappa value. So now let's see what Minitab outputs here. So first, within. So this is going to be within variability. This is the repeatability. Now remember, the kappa statistics don't matter because we only care about directional agreement. So we need to take a look at the Kendall's coefficient of concordance. We don't care anything about the kappa value. And you can see here that for each one of my operators, their assessment is greater than 0.7, which is what we're using as our acceptance criteria. So at least within, all of my operators are consistent. Next, we're going to take a look at between. So this is between appraisers. This is my reproducibility. And again, we don't want to look at anything with regards to the kappa value because it does not matter. We only want to take a look at the Kendall's coefficient. When we take a look at between assessment, we can see that I'm well above the 0.7. And again, that's an assessment of how much better than chance we did. So that is going to be deemed acceptable. And that, by the way, is going to be the value that you are going to report as your final attribute gauge R&R result is going to be that Kendall's coefficient. Remember, we don't have a key, so there's not going to be any assessment to the standard. In an ordinal gauge R&R or an ordinal attribute agreement assessment, there's not going to be any type of, there's generally not any type of key. So now what I'm going to show you is I'm going to show you an example that we actually run at Ford Motor Company as part of our black belt training. And what I call this is Scott's Garage. So when I do the training at Ford, you know, I've been an MBB for a long time, and I find some of the exercises that we have in our training material to be kind of simplistic. So I come up with ones that I call Scott's Evil exercises. This is Scott's Evil exercise number 4. That's called Scott's Garage. So in this particular example, what I'm doing is I introduce a service garage where we only serve GM, Fiat Chrysler, Honda, and Toyota vehicles. And of course, I tell my class we don't service Fords because they never break down. So to improve the efficiency of my 4 repair bays, each bay is dedicated to one brand and one brand only. And as the director of operations, the students must identify the brand of vehicle and direct them to the correct lane. Because what happens is if you direct the customer to the wrong lane, essentially what happens is that I can't service that vehicle in that lane, and then that customer has to drive out of the garage and back around to the front where they can pull into the correct bay. So that can be very, very annoying to them. So what I'm going to do is I'm going to show you how I set this up, and that way you can see an example. So these are the instructions that I give the students, that they're going to see 15 vehicles twice, and each picture is going to be shown for 5 seconds, and they have to write down the letter according to the make of the vehicle. So H for Honda, T for Toyota, F for Fiat Chrysler, which includes any.
For interrupting you, but we lost your audio for a period of time. Could you back up to the bottom of the previous slide, please?
Yes. I'm sorry about that. I apologize. So this is the slide for Scott's Garage, and so for Scott's Garage, this is an example that I use in class for the black belts that I teach. I actually call it Scott's Evil Exercise number 4. But in this particular one, I'm the owner of a service garage, and we proudly service the GM, Fiat Chrysler, Honda, and Toyota vehicles. I actually tell my class we don't service Fords because the Fords never break down. But anyway, to improve the efficiency of the 4 repair bays, each bay is dedicated to only one brand. And so as the director of operations, you have to direct the customer to the correct lane the first time. Because if the customer pulls into the wrong lane, well, I can't service that vehicle in that lane, and they got to drive around to the front, and they get to try again, which dissatisfies the customer. So I'm going to show you how this exercise works in class. So I basically tell them that they're going to be shown 15 vehicles twice, and that they're going to see each picture for 5 seconds. And they're to write down the letter of each vehicle make according to the code, and I've got the codes down below for the 4 different OEMs. But I tell them that they can't leave a blank answer. They have to guess if they're not sure. So if I take a look at this, this is clearly a nominal gauge R&R, or nominal attribute agreement assessment, because I have 4 categories. The categories don't have any particular order. So what we're going to do, this is an example. This is an example of a picture that I would take, and they would have 5 seconds to write down the answer. And of course, this one is clearly a Jeep product, which is a Fiat Chrysler. So I'll just let this run for just a couple of seconds so that you can see how this works. So you'll see that about every 5 seconds, it will advance to the next slide. And I'll only let a couple of these go through so that you can see how this is run. Okay, again, every picture is advancing about every 5 seconds, and they're told to write down one of the 4 letters. Okay, so we won't go through the whole thing, but that's an example if you wanted to give that in class. Now, normally what I do when I give this live is that I have the actual participants in the session participate in that gauge R&R, and believe me, it reveals some very, very interesting results. But what I've done here is the last class that I taught, I took their results, and we're going to share and see if we can take in what we've learned and as a recap. So again, each one of the assessments has a known correct answer, and that's shown in this column here, which is the key. And then these are my different assessors. Operator 1 had his 2 assessments, Operator 2 had her 2 assessments, and then Operator 3 had his 2 assessments. So we're going to see how they did in this attribute agreement analysis. So I'm going to go over here to my quality tools, my attribute agreement analysis, and then I'm going to put in my data is in these 6 columns here. I have 3 appraisers, 2 trials each, and their names were Jason, Haley, and Tom. And then my key is in this column over here. So that's how I'm going to fill this out. Remember, I don't have ordinal data, so I'm not going to put a check in the box here. Now I'm going to click OK. Okay, this is the useless graph that Minitab gives us when I go in that way. So I'm just going to close that out. We're going to take a look at the assessment, the session window. So here in the assessment window, we're going to take a look at within first. So this is the within. How well did they match themselves? So again, this doesn't matter whether they gave the right answer, just that they were consistent from one time they saw the same vehicle to the other. You can see that Jason did rather well. He matched 15 out of 15. Haley got 13 out of 15, and poor Tom, he only matched 8 out of 15. So what the cool part is we know Jason got a perfect score, so we really don't care about him. Let's take a look at Haley. So Haley, she got the Fiat Chryslers all right. She got the GMs all right, but she was screwing up the Hondas and the Toyotas. So it was very clear to me that Haley knew her domestic brands very well, but she didn't know her foreign brands well at all. Now I take a look at Tom. Tom, he didn't know his domestic brands very well, and he didn't know his foreign brands very well either, but he was much worse with the foreign brands than he was with the domestic brands. And in fact, for Toyota, he actually scored worse than Chance because he has a negative kappa value. The next thing we're going to take a look at is each appraiser versus the key. So again, this doesn't matter whether they answered the same. They had to, of course, answer the same both times, but now it's whether they match the key. Jason, again, scored perfect. He matched 15 out of 15 with the key. Haley got 11 out of 15 with the key. And then Tom got 7 out of 15 with the key. So the interesting thing here is you remember that Haley agreed with herself 13 out of 15 times. We saw that above. But obviously, 2 of those answers were incorrect with regards to the key. So again, for Jason, we really don't care. He's got 100% on everything. Haley, so she got all the domestic brands correct, but again, she was screwing up the Hondas and the Toyotas. So that's obviously where she needs her training. And Tom needs training on all the brands, but he did best with the Fiat Chrysler. Then we take a look at between. So again, this is our reproducibility. So they not only had to get them both right within themselves, but this is how many times they matched between each other. And you can see here that they matched 6 out of 15 times. So again, you can see here that the kappa value is reported for each brand. And then I have an overall kappa value as well for between. Then finally, we have the final assessment, which is going to be down here. So this takes into account everything: repeatability, reproducibility, and assessment with the standard. And this is going to be the value that we're going to report as our final value, 0.723. So my assessors did 72.3% better than Chance. And this is where I need to make my assessment. How good is good enough? The general standard, like I said, is about 70% or 80% better than Chance for the kappa value. But depending on the criticality of the measurement, that amount that you need to achieve might actually be higher than that. So I hope you found that exercise to be worthwhile. Now I'll head back to the main presentation where I'll go through a summary. So now that we've concluded this webinar, before I get to your questions, I hope that you got the following out of it. So the first is I would hope that you'd be able to state why an attribute agreement analysis is an important part of the measurement system analysis overall. Next, I would hope that you would now know how to set up and analyze an attribute agreement analysis for nominal data. And I would also hope that you would know how to set up and analyze an attribute agreement analysis for your ordinal attribute data. And I hope that the helpful hints that I gave you are worthwhile. So again, I want to thank you for your attention during this webinar. I want to thank the Statistics Division for co-hosting this seminar with the Six Sigma Forum. And I hope that you can take some of these things back that you've learned today back to your places of work to help you be successful. So at this point, I believe that Harry has been taking a tally of some of the questions that you've been asking during the webinar, and I'd be happy to answer those. So Harry, what do we got?
Well, so far we have variations on the same question, whether or not a copy of the presentation will be available. I will note that we have been recording this presentation, and we will be posting a copy of the recorded webinar on the Statistics Division's YouTube channel. And I believe if the Six Sigma Forum has a channel through which to distribute this, we can make a copy available that way as well. As far as copies of the presentation slides themselves, I'll have to refer that question to you, Scott.
Yes, as far as the presentation itself, what I can do is I can share the actual presentation itself. That's not an issue. However, the training session that uses the vehicles as the example that I showed, I cannot unfortunately share that that part of our training material because that's within Ford Motor Company. So the presentation, yes. The example, no.
How should people go about getting a copy of that from you? I do not have a means through which to distribute the slides.
Okay, so I think what I can do is the Six Sigma Forum has our MyASQ site that is live, and I can post the presentation within MyASQ for the Six Sigma Forum. So here he is, the statistics division. Is your MyASQ live yet?
I do not believe that it is.
Okay. How might we be able then to get the presentation to others that are not members of the Six Sigma Forum?
Is the Six Sigma Forum's MyASQ site publicly available, or is it restricted to members at this point?
I think it's publicly available.
So they should be able to go on to MyASQ, and it is something that you have to register for separately, but if you have an account on asq.org, the same credentials work on MyASQ. So you should be able to log into MyASQ and then go to the technical communities sites and see the Six Sigma Forums section of MyASQ.
Yeah, so what I'll do is I will have that posted by the close of business today.
Okay, are there any other questions? That's, let's see, okay, a couple more. If you don't have access to Minitab, are the formulas for assessment and CAPA available?
That is actually an outstanding question. I have seen the formulas for Kappa and Kendall's. They are based on permutations and combinations, which should probably be no surprise to those who are members of the statistics division. They would be available. I'm sure that you can find them in a textbook. I do not have them listed in the presentation, obviously.
And if I am not mistaken, both of those calculations are available as either directly within R or as functions within packages that are available for R. Next question, what about destructive attribute analysis? How would you go about setting that up?
Oh, that's an outstanding question. So thanks to the member that asked that. What we need to do with destructive ones, it really depends on what your situation is. So there are times where you can make an assessment. So for instance, if I have a destructive test and you're assessing the part after the test, that would be one way that you could do it. The other thing is that if you're evaluating a part and the test itself actually destroys the part, so I think I understand that might be where you're coming from. I think you would want to use the same guidelines that you would have if you were running a variable gauge R&R that is destructive in nature, and that is that instead of working with the same part over and over and over again, you're working with the same batches of parts instead. So the assumption would be that batches of parts would perform similarly, and that so parts within the same batch would perform similarly, but different batches would perform differently from each other. So you would set it up that way if your test itself was destructive and that's how you were assessing it. But if you're just assessing the part after the test, then you would just use this method here that I shared with you today.
Okay, thank you. I have another question that I don't quite understand. It's from Lennon Garcia, and it says, for the ordinal example, which is the conclusion? If I could ask you please to restate your question, and we'll circle back to it.
Okay, so I think I understand. Yeah, I think I understand what he's talking about. So what happens with an ordinal assessment is that there is no assessment with the key. So the statistical software only takes into account the within and the between assessments. It does not take into account the assessment with the key because generally the key doesn't exist. So what's going to happen here, like in this example where we were taking a look at you know, the ratings of the acceleration rates of the car, this final Kendall's coefficient of concordance would be what you would report, this 0.933. In the example that I showed you with the vehicle brands, this is, if I scroll down to the very, very bottom of my session window, I can't go any farther. This last table that shows the Fleiss's, I'm sorry, that's the kappa statistic there. It is the absolute final one that it shows in the session window. That would be the one that you would, so for this one here, this is for the nominal data. This would be the absolute last kappa statistic. That would be the one that you would report. And then it's the same thing. If I go back here, this would be at the very, very bottom of the session window when you run this assessment agreement. It's the very, very last one that you're going to report.
Okay. Next question is, how do you go about improving the kappa score once the study's done and the results aren't acceptable?
Okay. So that's an outstanding question. So if you remember back in the beginning of my presentation, I had said a lot of times when attribute assessment agreement analyses come out bad, or any gauge R&R comes out bad, it's generally because of the way that the operators are using the gauge. But with the nominal, it's a little bit different. So when I take a look at this, what we can do is we can go back in our session window and we can figure out exactly where people need help. So as an example, we have Haley here that really could recognize her domestic brands, her Fiat Chrysler and her GM vehicles, but she couldn't recognize the Hondas and the Toyotas. So if I were to train her and make her more aware of how to distinguish the Hondas and Toyotas from each other, that would obviously improve her kappa score for her, and then that would improve her overall kappa score. For Tom, obviously first with the ones that are non-domestic brands, but he's not very good with the domestic brands either. So I can see exactly from the session window exactly where the training is needed, and that's the good thing about the information that's presented in that session window, is it tells you exactly where you need to train your operators so that they can get better at making the assessments, and that's how you would improve your kappa value, and that's how you would also improve your Kendall's coefficient as well. Okay, Harry, do we have any other questions?
Sorry, I had muted myself there. Next question is software really necessary to do this analysis? Can't you easily do it by hand?
If you are not looking to get a kappa value or a Kendall's coefficient, and you're just going to look at the percent agreement, which is what the Minitab assistant is doing, then yes, you can do all the calculations by hand. So for nominal data, I would say definitely you could, especially if you're just looking at agreement. For ordinal data, you can do the calculations by hand if you would like, but they're going to be a little bit more complicated based on the equations for the Kendall's value. And then in addition, if you have more than 2 categories and you want to report the kappa value, it's going to be a little bit more difficult to calculate without the software, but it can be done. It's just going to take you a while.
Okay, next question is whether the MSA 4th edition, I'm assuming that's the AIAG Measurement Systems Analysis book, if that is still the current edition.
I'm afraid I'm not aware of that to answer, so I don't know.
And neither am I, so. By the way, you're getting a number of compliments that I'm not bothering to communicate, but if I can figure out how to capture them, I will.
That's very nice of the audience. Thank you, and I appreciate that feedback. That's very nice of you.
Next question is, do you think that there will be or should be universal kappa value guidelines?
I really think that it's dependent, and I say that very strongly. I think in some cases you don't need 100% agreement, but I think in other cases you definitely need 100% agreement. So for instance, when I was talking about the latch example with Ford Motor Company, there was no way that we were going to accept anything less than 100% for the kappa value. But there are some cases where it's not as critical, and I think you could settle for a kappa score that is less than 100%. So the guideline that's given, which is either 70 or 80, depending on which source you're getting that from, I think in some cases, and I'm not going to say a lot, I think in some cases that might be an acceptable level of acceptance. However, you can see that you can have significant disagreement and still achieve those scores. So if you're going to use those 70 or 80% as a guideline, I think you need to take those a little bit cautiously. I always aim for 100%, even in lesser critical situations, but that's just a professional preference.
Okay, next question is, can a nominal attribute R&R method be used for an audit form with 12 parameters to check? Yes, no, questions?
Yes, absolutely.
Okay, and I do have one request. If you would share your email address, is that something you would be willing to do, at least verbally here?
Yeah, so that's no problem. My email address is SSTER, B as in Bravo, EN as in November, at Ford.com. So SSTERBEN at Ford.com.
Okay, another question that I don't quite understand is, it says that is universal agreement, question mark. If you want to amplify on that question, just type in another question. If not, we'll just move on here. This says, do you take into account guesses on the questions?
Yeah, so I mean, obviously a blank would be definitely wrong. So that's why even in the classroom example, I say, hey, if you don't know, you at least got to write something down, because if you write it down, there is a chance that you're going to get it correct. But if you're guessing, it's very likely that you're going to get other ones wrong. So I would say that, yeah, it's pretty much taken into account.
And for ordinal data, why is the maximum number of choices 10?
Oh, okay. Yeah. So remember, I had said that for ordinal that you wanted a minimum number of categories as 5, and then a maximum number of as 10. I just give 10 as a general guideline because a lot of times, especially for a scale where things are getting worse, so like when I was showing the foam example, if you give people too many choices, it just gets a little bit too confusing. So that's why I like to limit it to, a lot of times my scales are 7 or 10. I've had them go up to 12 or 13 before, but it's been very rare. So the 10 is not like a definite limit that says, oh, there's no way you can go over 10. You can go over 10, but only if necessary, because you don't want to overwhelm your participants with too large of a scale.
Okay, how do you interpret the column 95% CI?
Okay, so what the 95% CI is as I'm showing on my screen here, this is, so for instance, it's this here. So they match 6 out of 15, so that's actually 40%. Basically, the confidence interval is going to be based on the number of samples. Remember, for my examples here, I had far, far fewer samples than you should have in any type of analysis that we're doing, and I kept the samples small just so I could contain it in a classroom environment. The confidence interval basically says that if you were to repeat this study over and over and over again with the same participants, that would be the confidence interval around this percent matching over here. So even though right now they match 40%, the confidence interval around that is that it would be somewhere between 16 and 67. That would be the actual that they would match if the study were run over and over and over again.
Okay, and I'll have to try to answer this one. Will an attendance certificate be provided? I believe you will receive an email from GoToWebinar thanking you for your participation, and you should be able to utilize that if you need credit for it, but if not, no, there will be no additional certification provided. You should make note of the time and date of the event and use that as your recertification credit. And said, was this a Minitab sponsored webinar? No.
Nope, definitely not. We use Minitab at Ford Motor Company. That's why I feature it in my presentations. But no, it was not an affiliation with Minitab.
More compliments. What type of graph or diagram would you recommend to best interpret the results?
If you're dealing with nominal data, as an example, if you want to show the results graphically, one of the best things to do is to use the results from Minitab's assistant. You can use those graphical, but remember, those aren't going to report the kappa values. What I've done in the past is I've run into examples where I've had an attribute agreement analysis that has not come out good. And then I've done some supplemental training, and then we've run it again. And then it was better, but it still wasn't acceptable. And then we ran it again with some more training, and we got incrementally better until we finally passed. And what I've done is I've just shown like a time series plot showing how the kappa score has increased as we've done additional training. That might be the only other advice that I could give you. But the Minitab assistant there does give some good graphical representations that you could use in a PowerPoint for folks that might not be familiar with the kappa value.
Okay, we've had a couple of people chime in to an answer with the of the question we had previously about the 4th edition of MSA. Apparently is the latest version available currently through the AIAG store. Someone wants you to
repeat. That's what I always love. That's all I love about our members. They're always willing to help us out when we can't answer a question. That's great, so thank you.
And we have someone asking what your email was again?
Sure, I'll repeat it one more time. It's SSTER, B as in Bravo, EN as in November, @Ford.com.
Next question, are there any recertification units? Yes, you should be able to claim 0.1 recertification units for your attendance at this webinar. It counts as an hour webinar. Could you please recommend a book to study measurement systems analysis?
You know what? I don't think that I have run across a book other than the standard training material that I have had at Ford. I don't know if the Indiana Quality Conference or the Indiana Quality Conference or Quality Council has a book, or it's in their study material, or there's a Brayfogle book. I don't know of anything in particular. Do you, Harry?
No, I'm not aware of anything other than the measurement systems analysis book available from the Automotive Industry Action Group, AIAG.org. And while I'm very happy that they provide that, reading it is about as much fun as a poke in the eye with a sharp stick. And again, one of our attendees says that if you look at the CRE body of knowledge, that's the ASQ certified reliability engineer, that there are recommended books on the subject. Someone else says that Wheeler has a good book on the topic. Practical Reliability Engineering is another book on the topic. And
oh, that's awesome.
We're at the end of our questions.
Well, outstanding. Well, again, I want to thank the audience. Some fantastic questions we had come through, and thanks also to the members that were able to answer some of the questions that we weren't. Again, I want to thank the Statistics Division and the Six Sigma Forum, of which I am members of both, for hosting this webinar, and I hope everybody got some great information out of it.
And if I may, I'd like to add my appreciation as well for everyone who attended, and ask that you fill out the survey that's going to appear after we close the webinar. We'll try to use that information as feedback to improve this series of webinars in the future. Thank you again, and at this point we will close the co-sponsored webinar, How to Set Up, Perform, and Analyze an Attribute Agreement Analysis, presented by Scott Sturbins and co-sponsored by the ASQ Six Sigma Forum and Statistics Divisions. Thank you.